No, I ain't got time to look at your homework, Jenkins. Got to get on. Was it human studies? Hello, welcome to Tweed's Garage, and yes, another Gearbox video. Yeah, you just can't have too many Gearbox videos. That's what I'm thinking. Well, that's what the Gearbox thinks you're not getting enough Gearbox content. So it's been throwing a few spanners at me. So we're trying to sort of get through that and hopefully to get it back together. But yeah, there's all sorts in this video. Oh, you like this one? Edge of your seat stuff. Okay, so let's get on. Let's get down to the bench. Right, this has been frustrating, but I think we're finally getting somewhere. As you can see, the gearbox is in pieces again. It's about the third time I've had it apart. Done loads of work on it. Within this cover itself, I found that this bearing, every time I was doing the cover up on the gearbox, it would get tighter. So I could see down this hole that this bearing was right up against the back of this cover. So there's meant to be a little bit of clearance. So then I was messing around with gaskets at first to try and cure the problem, but that didn't work. Tried two different thicknesses, but you don't want to go too thick. So, you know, it's just a bit of a bodge. And where the nut at the end of the shaft had been rubbing on the back of the case here, at the bottom of the recess, you can see here there was a mark here, but it'd been there a long time. And when I blued the nut up and tried it, you could see it was leaving a trace. And also the back of this bush, I blued that up and found it was rubbing on the back of the idler shaft as well. So I spent hours with different setups, managed to sort of machine the rebate a bit further out to give a bit more clearance for the nut on the inside of the housing. And then with that done, works out how to use the facing function on my boring head, and set this up again in the mill and clocked it all in, so I was running dead center. And then run the facing function on the boring head, which went quite well. It doesn't quite work right. The fast retract works, and then it should stop when it hits the stop at the end of the fast retract, but it does click out, but you're holding it with your fingers, you know, as gently as you can, and it just whips the handle out of your hand if you let it get to the end of the stop. So I was running it, but sort of letting it do fast return, but then stopping the machine before it got to its stop, and then reset it and done the next cut, and that worked fine. So I got a nice bit of a little bit of clearance in there. Spent a lot of time measuring the shafts in the gearbox with all the gears on and the bearing, and measuring the clearance between the back of the bearing and the inside of the casing, and you know, the recess inside the casing from the face of the cover. So done all that, thought we'd sussed it, put it all back together with the thinner gasket, and it just locked up tight again, locked up solid. So took it all apart to find out which shaft was causing the problem. It's this intermediate shaft was locking up, and we found there is an issue with this cover. The face of the cover and the bore of this bush is not 90 degrees to each other, it's out slightly. So as you can see, I've got a feeler gauge in here, and that's just over, I think it's just over 1 thou, so it's sort of like, yeah, 1/4 millimetre, and that, it will turn, but well, it won't, it's tightened up completely. But if I undo this, oh, it's not done up completely tight, that one's done up tight. Yeah, there's only one nut done up tight though, and it had clamped up again. If I just loosen this off a bit. And then slip in this one, which is 22 thou, or just over 0.5 millimetres. Pop that in there, then do the cover up, nip it up, and we've got all the locating dowels in as well, because I could sort of do it up before and it was all okay until you put these 2 dowels in, and it would tighten up. So that's done up, all nipped up tight all the way around with that 1/2 mil bush. Yeah, and you see that? That turns over lovely now. So that's running true in that bush, whereas before, where the cover is 90 degrees to this bore, it was jamming the shaft when you done it up. So when we hold the gearbox up for you, we've got, see there, it's tight there, and then there's a gap there, sort of just over 1/2 millimetre. So the plan is to set it all back up in the mill and then face it off, you know, clocking this to the 0, and probably with this feeler gauge pack it out, put this feeler gauge at the other end, so when I machine it, I'll machine off, leave light cut on this end, and then the sort of 0.5 millimetre coming out from this end, so that when that goes down, it should go down nice and parallel to where it is now, and then hopefully keep that shaft in line. But again, might need to sort of pop it back in the lathe, just face off the back of this bush where it's running on that shaft. This is the trouble, you see, you sort of, you know, do a little bit of machining somewhere, or, you know, as I said before, this has had, I mean, I've done this welding here, but this has had welding on it before. You know, how distorted this case has got and how much it's had taken off in its lifetime, and how well it was taken off. Might have just been taken off with a file. You just don't know, but we're getting somewhere. And I think, hopefully, once it goes back together, it'll be really, really nice. Yeah, it's because it's quite tricky. It was quite hard to turn over. You know, it had a lot of resistance to it. So I wasn't happy with it. But I think we're happy with it now. So, back to the mill. So I'm starting to think this gearbox is bloody cursed. I used the finger sander to grind out the area where the gear was fouling on the casing when you moved it around a bit, so it's got clearance. And being conscientious, I decided to, I did try and clean it out, and I did cover it up when I was doing the cleaning, but the bearing at the back here had a little bit of rubbish in it that I couldn't get out, so I decided to take it out again. What we done was, as before, the old candle wax thing, because it's tight in there. Apologies for the noise in the background. The neighbours appear to be on the old lady petrol, and it's making the ladies rather excitable. So yeah, just bear with us. So yeah, and it was all going so well. The bearing was about halfway out, and then it all went horribly wrong. Yeah, it blew the back of the gearbox out. So it shows you the power of wax being hydraulicked into behind the bearing. And it's really annoying because the bearing was coming out quite nicely. I don't know, Jenkins, it keeps going wrong. I think there's a curse. I think there's a curse on it. I don't know, it's all gone wrong since we went to the market. Yeah, what did you buy off that sort of Arabian bloke you saw at that market stall? A monkey paw? Oh, not the monkey paw.
Look at. It's just an ordinary little paw. Drive to a mummy.
What's so special about it?
He had a spell put on it by an old fakir.
So this is the trouble. This is, old aluminium, getting on a bit, and it just seems to be the constituency of Cadbury's Whisper bars, sort of all quite airy.
They've given it this new texture that sort of melts in the mouth.
Absolutely extraordinary. Tell me, do Cadbury's intend to sell this to the public at large?
I imagine so. Why?
Oh, far too good for them.
And granular, and yeah, it's just blown out. So yes, Randall, I did swear a lot, nearly threw it. Oh, that was a funny one. And decided to step away, go back down the house, have a cup of tea, watch a sort of crappy crime drama, and settle down a bit. And after about 3 episodes, an idea popped into my head how to recover this. So we managed to weld the cover okay. So we're going to give this a go. It's a bit more tricky because we've got this bearing surface here. Yeah, and the bearing was really tight, and you can see there where where it's been machined, it's sort of got tight ridges. You can see all the tight spots around there. Bit of sort of vibration in the machining makes the bearing really tight. So that will need looking at once we've done this repair. But yeah, how to keep it sort of flat and square. Nearly impossible, but I think we can do it. And what has happened is that the casting has broken right at the bottom of the bearing hole. So if you see there, that's where it's broken. They've actually sort of undercut at the bottom of the bore. So there was probably a little instep there and a sharp edge. And obviously that's where it's failed. But that also gives us roughly where our height is, or depth is for this bearing. So what I'm going to do is clamp it in the mill. So we've got it on a couple of parallels on the mating face there, long bolt through, and yeah, bit of clampage on the top like so, and again a couple of bits of aluminium each side so it doesn't push the bush out. And then we're going to machine down to this lip there, machine it all nice and flat and hopefully square. And then the plan is, it's half baked at the moment, half worked on. Turned up this big washer here which goes inside the gearbox and rests against the machine face just under here and comes through, and then we'll turn up a new top hat, this piece, with a little pip on the top, this piece. I might make this piece wider. There's no need for it to be smaller. It was probably just a casting spur that they've cut down. So I might make it a lot chunkier to add a bit more strength into the end of this bearing housing, and then turn it so it sort of just sits over the edge of the bearing. And then the plan is to try and TIG weld it all the way around. Oh yeah, what I'll do is turn the top hat and then drill a hole in here, put an 8mm tapped hole in, and then I can screw it down again with this washer and screw, clamp it against the casting so it's sort of flat against this face here and flat on the new machine top, and then that'll hold it in position whilst I'm sort of tacking it and then TIG welding it into position. So that's the plan. Let's see how this goes. I should really go next door and have some lady petrol. Sounds fun. Okay, an update. It's being a bit of a bugger. Well, probably more my welding ability than this being a bugger. But the problem we keep having is on that edge there. You can see it's started to collapse in. So obviously the heat's been getting in to that edge. But it needs to be thick enough because I have to machine this down, as I said before, to allow clearance for this clutch operating arm to swing past it. And all seems to go well until you machine that down. And although it looks okay, when I put in a bit of lighter fuel in the bottom of it, you could use petrol or something as well, some sort of thin solvent. I'll put some of that just in the bearing well there, and then just, you know, see what comes out. And the first time it was just pouring out, you could see it, so I had another go at it. And then the next time, or the third time, I sort of lose count. It looked okay, it wasn't leaking out, but when you rubbed your hand or your thumb past it and smelt your thumb, you could smell the lighter fuel on it. It was sort of, you know, by capillary action, it was leaching through, just sweating through the sort of porous holes between the casting and the weld. And then finally managed to get it so it wasn't dribbling through, but it did need another machine. But then when machining it away, yeah, again, it was sweating through. There was a couple of tiny little holes you could see in the weld build up. So the next plan was to try and build the bottom up, build this valley up, and then that gave me more meat to lay some more welding against this side, you know, and sort of push it that way, you know, without it all disappearing between the gap of the casting and this cap that I made. But unfortunately in this casting here, there's a load of sort of air pockets within the casting, and they just kept opening up and bubbling up through and blowing crap through, and it's just got harder and harder. So it's a case of cleaning it up, starting. So this is about the fit. Oh, and then what happened is a hole opened up on this side, so we had another, you know, possible oil leak to deal with, and that was because of the grub screw hole down there that holds the bush in place. As you see, the bush has also been taken out because it was loose enough, because it was hot enough. I managed to push it out, but where that goes, there's hardly any meat, you know, either side of this. In fact, it breaks through there, and it does rub, it does lock onto the bush just there. You can see where the screw threads have sort of rubbed against the side of the bush. And the other issue I had with the bush, where so much heat had gone in here, I put this in, you know, back in just to check the fit, and it wouldn't go in. It'd go about that far, and then it just got tight. But as you can see, take the bush out and it's all fine. So we have got a bit of misshapen casting where the weld pulled it around a bit. So I thought I might have to, but I'm resigned to the fact that I've got to try and attempt to bore these out, which is another nightmare of a job. But anyway, and yeah, I've got to bore this one out to clean that bit of the weld up at the bottom. You know, if I could get the torch in there, I got to the point that, you know, I'll just bloody weld it up at the bottom on the inside and then machine it back. But no, I can't. Yeah, can't get the torch in there. So we'll just have to carry on. So hopefully now manage to take that grub screw out, clean the hole out, clean the thread up, and then manage to sort of fill it. I can see that some weld has collapsed in the bottom of the hole, right at the end of the hole. So hopefully there's enough there, enough meat there, that there's no poker mark when I sort of machine this back to this face, which will be good. But we're getting to the point of, you know, if it leaks again, getting some of that red casting seal of paint, you know, they put on sort of Royal Enfields and stuff like that, I think, because they're porous castings. But yeah, it'd be nice to try and fix it by welding it and it not leaking, because it didn't leak before. But yeah, 5 attempts. I think we're getting to the point of, yes, we're going to just have to seal it and put it all back together and not tell anybody, because nobody will know, apart from you lot. Yeah, I know, Jenkins, I'm going to break the first rule of TV acting. I'm going to break the fourth wall. Yes, so I think we managed to weld it up as good as we're going to get it. Still getting a bit of porosity through there, but I've decided stop whilst you're ahead. I've welded it 5 times, put a lot of heat into this casting, and yeah, it's starting to get a little bit sort of saggage in the middle. You know, got distortion on here. I know this because the bush went tight on the shaft. I couldn't get it back in again, and as you saw when I put it back on the shaft, once it's out of the housing it's fine, so it's being squeezed too much. So we need to remachine this surface just lightly, and also a bit of distortion on the bearing recess, so that needs machining as well. But how to do it? Well, amazingly, that surface and that surface is spot on. You know, they're spot on the dot, but it sort of does drop away a little bit in the middle. Could use that, but side to side, you don't know how good it is. So really, the only good surface I got is the machine face on the outside of the casting, which I should imagine was used for some machining and setting up. So, but the trouble is, you know, how do you want to go in here, but you've got, you know, you've got to get this surface mounted flat. It was a bit of a pickle, couldn't quite work out how to do it, but then I remembered I've got a Bridgeport. Yeah, it's like sort of Swiss Army knife of milling machines. So what we're going to do, or what we've started doing, is we're going to hang the job, because you can do this on Bridgeport. Going to hang this job off the side of the table like this, and then have some mounting bars that'll bolt to the table, hang over, and then the gearbox will bolt up to it like that, and then I can go down inside it with my boring head and hopefully machine the bores, and then do the face cutting and get the faces flat again. If there's any high spots, take them off. Yeah, so how we done that was, yeah, thank you Gavin, bit of cast iron, no, bit of angle iron all the way from Solihull, and that's what's left of it. Yeah, I've cut 2 sections to make some mounting plates for the gearbox. What I done first was got my lovely Sumitomo shell mill. Yeah, very nice. Yeah, spent a lot of money getting new inserts for it, and a few clamps were missing, but it cuts absolutely beautiful, like a knife through butter, as you will see. And this stuff, this angle iron, I mean, it's sort of hot rolled stuff. It's got that black finish to it. Can be really nasty with sort of hot spots in, but yeah, look at this, look how it machines. And there you go, and there's the finished mounting plates. So 2 holes for the gearbox, and then 2 holes at 5 inches to mount on the slots on the table, and then they bolt either side of the gearbox like this, like that, supporting the gearbox either side, and nice sturdy bits of angle, nice and flat on the bottom. So it's as good as we're going to get it to machine those bores. But Mr. Tweed, your mill's not going to reach over there. Young Harold, it is. That is the magic of the Bridgeport. Hang on, let me put these down so we're not clanking around. Not only on the Bridgeport can you tilt the head this way, you can tilt it that way, you can nod it that way and that way, but also you can move it out this way, extend it over the table, and also the whole column swings round either way. Well, I'll do a full 360 because you can have a notching head on the back, so you can swing this round and have your notching head over this way. So I'll get this set up, get the gearbox mounted over here on the end of the table, boring head in here, and yeah, lots of indicating, setting up, trial cutting, and then hopefully we'll get somewhere where we can start putting the gearbox back together. Oh, the leaking, yes, I've got a liquid solution coming for that, so hopefully that will turn up before the end of the video. So yeah, but we'll get on with the machining. All right, let's get machining. Right, you can come out of there, you cause nothing but trouble. Okay, on the boring heads, this is my one I prefer to use. This is my Stanton and Thompson boring head. Does boring and facing, automatic facing. Yeah, really nice, really accurate, and nice and sturdy. Unfortunately, that wouldn't even fit in the mouth of the gearbox between the angle iron plates. So the next option was this Micromade boring head, similar quality to that, very nice. It also has boring and facing, automatic facing function on it. Unfortunately, it's missing, I think it's missing some of the parts. I've got to look into that a bit more to try and get that working. Yeah, I'm not quite sure how it works on there. I need to look into it a bit more. I would have used this one just for the boring. Unfortunately, it just has a centre tool position in the end of the boring head, which means when I moved this over to get to the size I wanted, there wasn't enough clearance around the gearbox casing to have this spinning around. So couldn't use that one. Yeah, see, this one has three positions, which is really useful. You know, you can sort of hardly have to move this carriage out away from the boring head when it's working. So yeah, so we had to, and also it was the depth as well to get into the gearbox. This would have just about done it with a long boring tool on it, but then, you know, you've got longer the boring tool, the more chance you've got of vibration on the work. So the next option was, you know, I've got a cheap import boring head that had a Morse 3 taper on it, so it wouldn't fit in the mill, but luckily I've got a Morse 3 taper adapter and then a quick change tool holder that goes on the Bridgeport, and this goes into it, so that gave it, you know, really decent length down into the job, and as you can see, it works really well. And then, yeah, see, this has got an offset tool position as well, so it means you don't have to move this out so far, it's more adaptable. So yeah, so this is the one we will be using. Unfortunately, yeah, cheap import. Boring bars, but you know, takes what you get. Okay, sounded terrible. Let's get a pointy stick. Sounded terrible. I've had it sort of, yeah, the tool hit a sort of lump of welding slag that didn't look that big when you looked down into the bore. But yeah, when the cutting tool hit it, it bounced and then I think set off a bit of a vibration in the boring tool itself, and it sort of proceeded to sort of bounce in and out, taking cuts as it went around the bore. So yeah, it's sort of pretty rough, but where it's been bouncing in and out, it has actually left the original size of the bore on the outside edge. So the bearing's still a tight fit down through there, and then yeah, the bottom 2/3 is machined nicely. I sort of went back in there really carefully, come further out, and just gradually took that bit of weld down, you know, in tiny increments, because it was really tough. Yeah, the tool didn't like it at all. So yeah, we managed to save it. You know, not happy with it, but you know, the bearing's still a sort of tap-in fit. But what we will do when I put it in is put a bit of bearing fit in with it as well. So it's not going to go anywhere. But what I need to do first is, with this liquid sealant stuff I'm getting, I need to get into this corner to flow it in there so it sort of gets sucked in and drawn in through the casting to seal up all those pores. This one cleaned up okay. It may look like it was cutting here and here, which it was, but this hole is slightly oval. But if you actually look on the original machining, it's like that before. You know, there's a sort of, just here, there's a little bit of original casting, sort of a little scallop of it there that the machining hasn't touched. So yeah, so the bush is a nice tight fit in there. So we heat the case up, drop it in. I've made this threaded rod like this to go in that hole there. That will go in like that, and that just gives me a guide to drop the bush in like this and keep it in line, so that when it goes in, that hole will be in the right place for the securing screw to go in. But also on this we'll put bearing fit on this as well, all belt and braces, so they don't go anywhere. So yeah, almost calamitous, but yeah, trust the mill. 3 days, 4 days work, machining, welding and all that, and then the mill takes sort of 2 seconds to attempt to wreck the whole job. There you go, mustn't grumble, carry on. So there you go, drama after bloody crisis. And yeah, managed to fix the first one quite nicely, pleased with that. The second one sounded worse than it was. Yeah, so I think that's okay, that's recoverable, we can work around that. So what we'll do is we need to cure the leak in the casting through the welding and the casting. The stuff I talked about has turned up, but we ain't got time in this video, So we'll do it next time. Yeah, and then I will put the bearing in. I don't need to put it in yet until I've cured that back of the casting. And then when I put that in, it's sort of a push fit in there. We'll heat it, drop the bearing in, let it cool down, and then sort of put a bit of a bearing fit in there as well. So it's all belt and braces. Yeah, I hope you liked the video. If you did, give us a little like, and if you like what you see, subscribe, and we'll see you next time. Yeah, hopefully with the gearbox back together. No, oh, I know, Jenkins, I've cursed it. I've cursed it. Oh, bloody hell. Where's that monkey paw? Yeah, I know, Jenkins, I'm going to break the first... No, I ain't got time to look at it. Yeah, what did you buy from the monkey? What did you buy from the monkey the other day?